analysis. So now I said cut, and then I'm going to go here and I'm going to say paste special, transpose, turned it into a column. And then what I have to do, oh, I knew what the gap was when our names are in there. I just have to get rid of these here. And it's a little tedious because I don't know any global way of doing it. In fact, I can show you what I really should have done. What I should have gone down is, here's a trick I'll show you. So what I do now is I'm just going to paste the transpose here. Okay, then I'm going to hold down the control key. Because now I'm going to delete whole rows. You see I spent a lot of time. And delete selected rows. And heaven only knows why that happened, but it jumped a little bit left, but there's all my numbers that I want, right? So I'm going to get rid of these guys because somehow hitting cut didn't work. So just a delete key in Google Sheets. So there's, oops. This is my list of delta T's. Copy. Delta T, excuse me. These are my T averages, yep. Paste. There they are. So I'm going to get rid of all this. I'm going to do this again for some other data so you can watch you can try and follow along with me. So noticed I needed 2 centimeters, and there it is. So I'm double checking. I want the average. So I can do a spot check. Yep, 0.67, 20 centimeters. The average is 0.89. Yep, there it is. Okay, so let's do this because I want you guys to be actively participating. So we're going to, well, it automatically saves. So now we're going to make a copy. And, whoops. And we're going to save it with our name in the file. We're not going to share it. All right, I've got the chat window in the other screen. So if you have questions, of course you can always unmute. Okay. So now I've got all those average values of the time. And now I want my error bars. So let me show you how I did that. So I had to do it in 2 steps. First of all, I'm going to select them all the way across. And I'm going to copy them. And now I'm going to scroll down to an unused part of the, maybe I'm going to scroll down to it. Now it wants, oh boy, an unused part of the spreadsheet. And I should have gotten rid of these things, but I don't want to lose my clipboard. So I'm going to paste special. And I'm going to paste values only. In Excel, you don't have to do this in 2 steps, but on Google Sheets, we have to. So I'm going to paste values only. And then I'm just going to get rid of this. Delete there. Okay. So now I'm going to reselect all my plus minuses. This actually, I suppose, could be sigma, not delta. My plus minus. And I'm going to say copy. And this is great because I'm going to kill two birds with one stone. And I'm going to say paste special. Hey, you're playing with Marcos. That's all your parents need to see. You're paying all that tuition. And now I'm going to say paste transposed. So it turned a row into a column. That's what it means. But now it's still got all its crap interspaced. So it wouldn't let me, so you can hold down the control key to select things that aren't next to each other, but it wouldn't let me do a delete, see? But it will let me do this. So I can select that row, hold down the control key, so I have to select every other row, or at least select the rows I want. And I need to scroll down a little bit. There we go, holding down the control key. And now, if I do a right mouse click, I lost all my work. Oof, so I have to do it again. This is the only thing, is if you screw it up, it's a little tedious. But if you get better at it than I'm doing, it does save a little time. I don't know. It would be nice if we could somehow figure out a way to autofill it. Well, what you would do is set up a spreadsheet tediously once and then reuse it. So if I right mouse click there, yeah, I see I kept it over the number here, but I should have kept it over a cell. And delete selected rows. And they're gone. And there's my all my delta t's, my plus minus. So I copy them. And then I come up here. Whoops, got to be a little careful because we have 0. And we paste, and there they are. So let's see, this is in CM. This is T in seconds. And this is, oops, I gotta put my apostrophe plus minus T in seconds. Excuse me. And so let's see, I think that this can be, we'll make that 2. And I think we'll make these 3s. All right, and that pretties it up, huh? And in fact, we could have anticipated. Well, what happened? Oh. So this one here is just going to be 0. What time do we have? Huh? We're doing all right. So we're almost at the point. Well, I wanted to teach you the new thing. So So we have V average. And then we have plus minus V average. Then we have, excuse me, V instantaneous. And I forgot units. V instantaneous. So that is equal to the distance divided by the time. Okay. Sorry. Well, with that one, well, first of all, we'll just fill these guys before we do anything else, and we'll just call that 0 because that's what it is. And we can also, this equals to 2 times the average we figured out. And isn't that interesting, huh? Of course, don't forget it's in centimeters per second. Oops. And then this one is, oh, it's pretty straightforward since there is no, we don't have, we're not quoting an error on X. We could, and perhaps we should. Now, I tried doing this and it didn't work very well. About, I just want to be able to, no, I want to be able to write on the screen. It's not, how do I get escape? Okay, that worked. All right, so I'm gonna have to go back to the notes here. And then I can copy paste it into the spreadsheet. That's right. Okay. So we want to figure out an error on a derived quantity. So we go to our trusty table. And this one is used so often, I basically have it memorized. Yeah, it looks like a blue pen, huh? So we have F equals A over B. So our equation is V bar equals X over T. So, well, should we add in well, I guess an X error would be useful. Why don't we call it plus minus 0.5 centimeters? Okay, so we're going to let's add in . insert cell, shift to the right. And let's say, what can I call this? Half a centimeter. Plus, minus x. And, yeah, why not? And we can just say that's the same for all of them. Maybe, yeah, there we go. Okay. So let's, okay, there we go. So that, if we remember, each one of those has its own error. So that means that sigma V bar is going to equal V bar times sigma T over T squared plus sigma X over X squared. Whoops. And we're going to square root it. So if we can now select, and we're gonna copy, oh, that I don't understand, copy, and then go back here, and so we'll paste it, there it is. So this is not going to be equal to 0 now. So it equals the average times, let's see, SQRT and open parentheses. And I'm going to just open parentheses again. So it's plus minus T divided by T, close parentheses, raise it to the second power. This is certainly hard to do, I know. And it's plus minus X divided by X. Oops, that's going to give an error there. Well, we'll see. I'm going to keep going. Raise to the second power. Yep, and then close the square root. And just hold on a minute. I want to fill it in. Wow, that's pretty big, huh? That's a big error. I'll have to. I gotta see if I believe it. Let's see. Sigma J36, yeah, is sigma T plus minus T over T. Yeah, those are big delta T's. Okay, that's right. And I believe it. Can you guys see that? So you can see how I typed it in. Yeah, Mark, I'm just looking at playing with marbles. I hope you didn't tell her my name because she's going to write a letter to the university and goes, what kind of hell professors are hiring over there? I just got my kids to stop playing with marbles. Now he started again. So you can see how even with this technique, we didn't beat, the error bar is going to be quite large. And so this would mean that it would have probably been better. So here's some thoughts for your later on in analysis and results, that probably it would have been better to have people pair off somehow, because it's very difficult to do the stop and start and the timing. And then probably we should have done it, each one of us should have done it 3 times and typed in an average into the boxes. So those are some ideas of how to improve the error. And so this one here, we'll jimmy it, because we can get rid of the term with the, with the 0 divisor. Yep. And that should give us an answer. Still, what did I do wrong? J35 over I30. Oh. But, wait a minute. Did I get this backwards then? Maybe I did. Let's check it. Let's see. Okay, J36, which is the parable, divided by I36. Yeah, that's okay. Then H36 divided by D36. Yep, I believe it. So why is it? And then K36 is the V average. Yep. What is this? Why? That is right. Okay. So this one, right, it just can't have anything. We're just gonna get rid of that for the time being. Let's just without any, I'm just going to do that. Notice the plus minus grows, but the fractional error is staying pretty good. And then the plus minus here, if I double it, do I double the error? No, it's just for now, it's, give me a minute. Yeah, I think you just double it. Let's, well, we can reason it out. So if it's the same equation for A times B, and if one of them has no error, then right, square root, so it's just equals to V instantaneous times the plus minus V. That's it. I leave it to you guys to figure that out. And of course, that can't possibly be right. Because I forgot to divide. Yep, okay. So in this case, it's the same formula, but I have to put the plus minus V average over V average times V instantaneous, and I forgot that part. So I have to divide by V average, there it is. And of course, it's gonna nag me again. Wow. Excuse me, that seems kind of large. So it would be V average plus minus V average over V average times V instantaneous. Yep. That's a huge error bar. Okay. So we need, we're going to need our slope. Oops, slap equals. And we know that our acceleration should be about 0.07. So call it 0.1. And we know our y-intercept should be 0. Well, nobody is complaining to me. It sounds like we're all good. And yeah, and through all this trouble with the error bars, you can't easily put error bars into Google Sheets, but there's more reason to it than just simply to torture you with the calculation. You'll see in a little while. So the fit line, and we're going to add some new stuff, the residuals. And we're going to call the residuals squared. Oops, and I goofed. I didn't quite leave enough room. So I want to insert cell, shift to the right. And right, we'll just keep that much for the time being. Okay, so this is equal to, of course, the slope time, and we need the dollar signs, which you can get by just clicking F4 times, and the X value is the time, plus the y-intercept, and again, hit F4 to get the dollar signs. Whoops. Oh boy. Yeah, that sure doesn't look right to me, but let's just stick with it. We may have made a mistake somewhere. I'm not quite sure where, but what about if we put 10 there? Okay, I like that. It could be that my like centimeters and everywhere might have been a mistake, or it could be, as Nicholas was saying, could be related to the way I define the angle. But that's all right. The data is the data. Mother Nature never lies. Okay, so this is something we've done before. And next is residuals. What is residuals? Residuals is the data minus the fit. So it equals V instantaneous minus the fit value. And that somehow seems that's okay. Oh, I see. What did I do? No, I'm liking it. Somehow I've done something wrong here. I still don't know what. but we will figure it out. I mean, I may have to play with it and get back to you. Well, now we go. Now we're getting some negative ones. We would expect some negative ones. When I plot it, you'll understand. And of course, the residual squared, that's easy. It's this squared. And we're running out of time. Okay. And we fill it in. And let's put this. Now, what I would say is we'll go through this, but you can also have a look at the rest of the videos. And this is going to, you'll see the whole explanation of what we're doing here. We'll plow ahead for sure. So we want to add, two things. We want to add, let's see if they have this fancy symbol. Instead of using, we'll just call it the sum of the residuals equals, and the sum of the residuals squared. And I suppose we could put the equal sign there. Equals. And so that is equal to sum of the residuals. Enter. And this equals the sum of the residuals squared. All right. Everybody with me? Now, I wonder if Google Sheets will let us do this. So we want to select the time, and we want to select the be instantaneous. And so I want to insert a chart. And let's insert a scatter plot. Well, that doesn't look as bad as it seems. Don't forget, it's got big error bars. And so we want to add a series. How do we move this? Let's put it down here. And then, so let's add a series. No, we want to use column, row. I hesitate to click that, but okay, that claims that's the late here, right? What happens if I do this? Okay. All right, so I'm going to add a series, and that is going to be the fit line. And there it is. And of course, we need the fit line to be a line. And now I'm trying to remember. Yeah, well, you know, we can do, in this case, we can use the trend line. I forgot how I solved this, but we can use the trend line for this one. Okay. Now, remember when you draw a fit line, you try to have equal numbers of dots below and equal numbers of dots above. And if you think about it, that means that if I do that, then the sum of these should become 0. So if we go to 42, look at that, it got smaller. And what about 43? Got smaller still. Now, it could be that we should let this thing not tie it to be 0. Well, that made it get bigger. But what if we made this 44? Ooh, huh? Look at that. So now we have an optimization technique to make sure that our, can you zoom out so I can see the, okay, what is, you mean above this table we created, Marco? Or just the one we've created? Yeah, let me see. Oh, I thought I did that. How's that? Welcome. Now, the thing is, though, that at some point, sure. Okay, so this is our data, right? This is our the fit line. So the residuals are the data minus the fit. So what that basically is the, let's see, if it's minus, this would be positive, right? So it's the positive vertical distance, or in this case, the negative vertical distance from the dots to the fit line. And think about it. That's what, yeah, right, of course, Jesus, of course. That's right. And then also, you can, for another point of view, those YouTube videos. Yeah, of course, you have to get the class. Yep. So if you think about it for a minute, if we're trying to make the fit line have as many dots and also the distances below equal the number of dots and the distances above. And yes, you're welcome, Raymond. So in a sense, if you think about it, that means that the perfect fit, the sum of the residuals would equal to 0. And if we always were hand operating our spreadsheet, our computer program, we would be done. The reason we use the residual squared is because, watch this, we can produce an absurd result let's see, minus 25. Let's try that. And so we need to, we can go down even lower. Let's say minus 30. And if you watch the sum of the residuals. Got small, oh, now it went positive. So let's try minus 35. And now it's negative. So minus 37. And notice now the sum of the residuals is even better than what it was before. But obviously, this is a shitty fit. So what happens is, if we use the residual squared, now I'm going to hit the undo button. So I want everybody to, we'll do it a step at a time. And we're going to look at the quality of the fit, and we're going to look at the sum of the residuals and the sum of the residuals squared. Okay, so at this point, we've gotten the sum of the residuals closer to 0 than we had before, which is like, well, it should be good, but when I look at the fit, it stinks. So I go like, oh, of course, it undid the movement, sorry. So I undo, and let's see. So, okay, so the sum of the residuals got bigger, and so did this, and the residuals squared. And you notice the sum of the residuals squared is staying kind of the same. Got bigger, much bigger, and huge. But now, when I have this pretty small, notice that this is the smallest value yet of the residual squared. So the math of this is difficult, but what it does is, instead of having, if I were to plot so this is, you may have heard the word parameter space, huh? So our parameter space, oh gosh, like for example, the slope. Let's do a better one here. So if I vary the slope, what we'll see is that the residual will go something like this. So it's not bounded, whereas the residual squared will do something like this. So now it's bounded. So the best fit is, of course, the residuals will be close to 0, but I can, in principle, as I demonstrated, say the math is tough. I can make a situation where the residuals are 0, but the sum of the r squared is way up here. So the reason we do this is because we can tell a computer to minimize the residuals squared. If we tell it to minimize the residuals, there's no guarantee that it's going to make the beautiful fit that we expect. And oof, okay, where did it go? Boy, I'm running out of gas. Here we go. Okay, so anyways, we got it on recording. I will, we can add the error bars to this. There'll be crude error bars because of because of Google Sheets, but I can see where the way to go would be to use a fraction, because I think the fractional error is pretty constant here. But anyways, you guys better get going. And then we have review session I got to get ready for, and I'm already exhausted. So great, guys. I hope this was as fun for you as it was for me. I think this was really, really cool as hell. I hope you learned something. Well, and so good. I'll see you all soon. End.